Hey Alex, I'm going to try and cover your questions here in this video. The first one was, how are you going to know when you have to use the normal curve and normal CDF? So basically, the question is going to have to ask, what is the probability or what's the likelihood, something like that. And then in the stem of the question, they're going to have to tell you something about the shape of the sampling distribution. Like here, what is the probability? Okay, this is going to involve that. Does the poll give convincing evidence against? This is a way of asking probability. If we're dealing with proportions, which both of these questions are, it's not going to talk about the shape like approximately normal, skewed left, skewed right. Let's see some other ones here. What is the probability? So anytime they're asking about a probability in this unit, you're going to want to use the normal distribution. Let me show you when we dealt with means from quantitative data. Find the probability, and here you can see it says approximately normal. They're talking about the shape. Let's see, right skewed distribution. There's them talking about the shape, how likely it is. So again, probability. Calculate the probability, skewed to the right. So if it's quantitative data, they're going to talk about the shape being approximately normal or skewed left, skewed right. If it's categorical, they're not. So hopefully that answers that first question. The second question, can I explain the greater than or equal to 30 rule? Yes. Where is this? Okay. So here's our population distribution. If I take a sample of size 5 and calculate the mean, 1, 2, 3, 4, 5, there's the mean. It's going to do a sample of size 25 in a minute and calculate the mean down here. This is starting to create the sampling distribution. If I do this a whole bunch of times, I can see that both of these distributions are approximately normal, these sampling distributions. It doesn't matter if I have a really small sample size, I'll change it to 2 or 25. The shape matches the population shape, approximately normal, which is good. We can use the normal curve. We can do normal CDF to calculate probabilities. The problem comes into play is, what if the population is not normally distributed? I could see when I take a sample of size 2, trying to fit the normal curve, it's not a good fit. Let me take that off for a second. I can see that this distribution is skewed to the right. But when the sample size is large enough, in this case 25, because this doesn't go up to 30, that the normal distribution starts to be a really nice fit. And we could use normal CDF to calculate probabilities. So the n greater than or equal to 30 rule is saying if the population is not approximately normal, whether it's skewed right, skewed left, just some really crazy shape, or maybe it's uniform. Let me change this so you can see if it's uniform. If this is roughly uniform, there, somewhat uniform, and we do the same thing. If the sample size is large enough, it's going to be, the sampling distribution is going to be approximately normal. Doesn't matter what this looks like. So that's the second question, that the central limit theorem means the shape of the sampling distribution will be approximately normal. It doesn't matter what the shape of the population looks like. All right, third question, can you explain the 10% rule? I'm confused on when we need to use it. Explain it if it is usual or not. Anytime you're going through your whole CVS stuff, anytime you're talking about variability, you're going to need to use the 10% condition. For proportions, you have this formula for standard deviation, the square root of p times, let me try and just write it on its separate. Okay. All right, I'm just going to write it over here because this tool is a little bit easier to use. If I could actually click on it, that would be great. Okay. So, or maybe not. Is this thing working? Okay, that's working. Can I? All right, apparently I'm having absolutely no luck whatsoever, so let's come back here. So this is p times 1 minus p, and this is terrible, sorry Alex, divided by n. And then for quantitative data, it's the population standard deviation sigma divided by the square root of n. So this is for proportions. This is for means. Again, categorical data, quantitative data. So anytime you're doing one of these problems and you're checking the variability in hopes of eventually using the normal distribution, you're going to have to check the 10% condition. And the 10% condition we check because we're sampling without replacement. So technically speaking, the sampling that's happening is not independent. But the 10% condition says that the sample size is really small compared to the population size. So if that's met, it's okay, and we can kind of assume the events are independent. So the 10% condition just is saying, in general, that the sample size is less than 10% of the population size. So if I sample 30 RH seniors, 30 is less than 10% of all RH seniors this year, which is true. There's about 400-ish. So that would check, and then I could go ahead and if I was just sampling like, I don't know, their eye color, that's categorical, I could calculate the standard deviation. If I was calculating how many colleges seniors applied to and I sampled 30, then I could go ahead and calculate this because that's quantitative. So hopefully that answers that question. The last one, when the answer is statistically significant, does that mean it's common or uncommon? And if it's less than 5%, then it makes... Okay, second part of your question. If it's less than 5%, it's significant, right? Yes, this is true. If it's statistically significant, that means that it's not likely to happen by chance. So it's an unusual result. So it's uncommon. So I hope I answered those 4 questions. If you want to stop down second block, I have a class, but I can try to tackle a question or two that you have. Or if you just want to work in my room, you can work in the back of the room. You're more than welcome. So, all right, I will see you later.